Hi Coach L, this is tutorial 4, driving an RGB LED, and let's go. This is the code for driving RGB LED basic. Here we're going to create variables for the pin numbers, and they're going to be constants, so they don't change. So constant integer red pin is going to equal 5, green pin is going to equal 6, and blue pin is going to equal 9. So the red pin is going to be responsible for the color red, green pin is going to be responsible for the color green, and blue pin is going to be responsible for the color blue. Here, display time is going to be how long the cycle of colors is going to last in milliseconds. It's going to be 10 milliseconds long. In the void setup, we're defining the variables for the pins. So the red pin is being created as an output, the green pin is being created as an output, and the blue pin is being created as an output. So all the power is going to go to each of those 3 pins. For void loop, here the main colors is showing the custom function called the main colors, and here is going to be where the custom function is written. So here's the function, and it's all written down here. So digital write are red pin low, digital write green pin low, and digital write blue pin low. All is turning all the LEDs off, so no light will come from the LED. It's going to delay for 1 second. Then here, digital write red pin high, green pin low, and blue pin low is just the red is going to turn on, so just the color red will show. Delay for 1 second. Digital write red pin low, digital write green pin high, and digital write blue pin low is going to turn just the green pin on, showing just the green LED. Delay for 1000 milliseconds or 1 second. Digital write red pin low, digital write green pin low, and digital write blue pin high. So it's just going to turn the blue pin on high, showing just the blue LED. It's going to delay for 1 second again. Here we're going to create yellow by turning the red and green pin on, so the lights will mix, turning the LED yellow. Again, we're going to wait for 1 second. Here we're turning on the green pin and the blue pin to create cyan, and we're going to wait for 1 second again. Here we're going to turn on the red pin and the blue pin to create purple, and we're going to wait for 1 second again, and then finally we're going to turn on all of the LEDs on high, turning on them on, creating the color white, and then finally delay for 1 more second before looping up to the top again. And that's it. This is the board working for the driving the RGB LED basic code. So we have the white wire here connecting to the 3.3 volts to the positive inputs. Then we have the black wire here connecting from the ground to ground the negative inputs here. Then we move to the RGB LED. And the red wire here connects from pin number 5 through the 100 ohm resistor into the anode of the red part of the RGB LED. Then we have the green wire here that is bringing the information from pin number 6 through the 100 ohm resistor into the green LED of the RGB LED. Then we have the blue wire here that is bringing the information from pin number 9 through the 100 ohm resistor and into the blue LED of the RGB LED. Finally, we have the black jumper wire here that is grounding the RGB LED by connecting to the negative inputs that are grounded by the black wire into the ground bar. And then we see it working. It cycles from red all the way through purple. This is driving RGB LED modified. Using an RGB LED and a potentiometer, I can control the color of the LED with a potentiometer and show 6 colors: red, yellow, green, cyan, blue, and purple. Here, I am creating variables for the pin numbers and making them constants because they will never change. Constant integer red pin 5 equals 5, green pin equals 6, and blue pin equals 9. Here is going to create a variable called sensor pin and initializing it to have a value of 0, which is going to be the analog input that the pot is connected to. Here. In pin mode, in here we will set 3 pin variables as outputs: pin mode red pin output, pin mode green pin output, pin mode blue pin output. This will send the information from those pins to the red and green and blue LED of the RGB LED. Void loop. Here, I'm going to create a local variable to store the sensor value called sensor value and use the analog read function to read the sensor pin and store the value back into the sensor value. Here I'm defining X as sensor value to easier write the code down below. So, if X is less than or equal to 170, then we will go down to here. Then the red LED will just turn on because red pin is on high and green and blue pin are on low. If X is greater than 170 and X is less than or equal to 340, then the red pin and the green pin will turn on, creating yellow. If X is greater than 340 and X is less than or equal to 510, then just the green pin will turn on high and the other will be on low, so be off, so creating the green LED. If X is greater than 510 and X is less than or equal to 680, then both the green pin and the blue pin will turn on, creating cyan. If X is greater than 680 and X is less than or equal to 850, then just the blue pin will turn on, creating the blue LED. If X is greater than 850 and less than or equal to 1022, then red pin and blue pin will turn on, creating purple. And then we'll loop back to the top, and that's it. Here's the board for driving an RGB LED modified. So again, we have the white wire here that is bringing the power from the pin 3.3 volts into the positive inputs, and the black wire that is grounding the negative inputs by connecting to the ground input here. And then we have over here with our LED, again we have the red wire that is connecting from pin 5 right here through the 100 ohm resistor into the anode for the red LED and the RGB LED. And then we have the green wire right here that is connected to pin 6 here and is going through another 100 ohm resistor into the green LED of the RGB LED. And then we have the blue wire here that is connected to the pin 9 here through the 100 ohm resistor into the blue LED of the RGB LED. And then we have this black wire that is grounding the cathode of the LED into the negative inputs that is grounded by the black wire. Then we go to the potentiometer. That is the white wire is connecting the potentiometer to the power that is connected to the 3.3 volts. And we have the yellow wire that is connecting the potentiometer to pin A0 right here. So the sensor value can be converted from analog to digital. And then we have the black wire to ground the potentiometer. That's all the wires. And then, so here we have the board working with the code. So as we go all the way to here, it's going to be red, and it's going to turn yellow, and then green, then cyan, and then blue, and then purple finally. See if we can get the cyan a better color. Blue, cyan, green, yellow, red. And we're done.